Welcome back, and now I am going to describe about the overfitting as a model error. And last time we have shown, or I have shown you the formula. Error is equal to some bias plus variance plus irreducible component, and overfitting is the biggest problem in the machine learning and deep learning, and so is the data science. So what is overfitting? Overfitting is exaggeration version of the saying that I fit on every data set of my point. Now look at here. A bias variance trade-off goes hand to hand with a very small problem in the machine learning called as overfitting. So if you look at the two diagrams I have shown here, on the left hand side you can see a straight line going through majority of the points, not majority of the point, but majority of the points are lying on the both sides of the line. Okay, so this is called as a good fit. And on the right hand side I have shown another curve shown by the blue connecting all the dots. Now in practice, the right hand side appears to be a better one than the left one. In machine learning, the right hand side is the worst because your model is traveling all the data point. So when your model is traveling all the data point, it is going up, down, up, down, up, down, up, down. So you have a lot of oscillations around the center, and when you have a lot of oscillations around the center, we call the data as having a most of the training and test accuracy problem. Okay. So if your data is too simple, if your model is too simple, it will cause large number of errors. If it is too complex, it will memorize the data too well. So this is what we call as a memory. Your data or your model has memorized the all the point. It is exactly putting a joke is equal to, if I have a parrot and the parrot is being taught to welcome everybody, the parrot will not be able to identify a difference between a normal person and a thief. That means my model has overestimated the things. Okay. So a overfitted model remembers the data too well and it acts like a database. Suppose that our housing data set contains some lucky deals where previous houses had a low price because of the circumstances not captured in the data. So a overfit model will memorize those examples too closely and predict the incorrect pricing value. So when money comes into picture, a model has to be more and more rigor. It has to be tested thoroughly on multiple data set, multiple data point, and then it has to predict a correct value. Okay. So now having understood the error decomposition, we can use it to a stepping stone for a design of a model testing. So you can see here, this is what we call it overfitting. So overfitting is a big problem, and we have a lot of techniques available in deep learning for reducing the overfitting. A first method of avoiding the overfitting is I divide my training data or my entire data set into three parts: test, validation and training. So when I put a data or when I train my algorithm or a model, generally we start with the train data and a test data. So let us see here. We need to determine how to measure the model error in such a way that it will correspond to the real model performance on a unseen data. So if I know the question before my exam, I really do not use my brain. When I am not using my brain, I have not learned anything. So that is what we call. So a model has to be tested based upon the unseen data. So the answer comes from the question itself. The okay, we will split all the variable into two sets, a training set and a test set. So I have a training data, I have a test data. Now you can see here almost the training data size is double of the test data size. So that means I have become a threefold. 1/3 is being given to the test data and 2/3 is given into the training data. Now the problem is, if your training data, in the training data, if I sample the data point and randomly all other points are being not coming into the picture and some points are coming repeatedly, then my training model also fails. It will over what we call fit. So we will use a training data set to train our model. The test set acts as a model for a unseen data, and you should not use the test set in the training process. So the test data should not be visible to the model at all, because if the model sees a test data, it will not be able to justify on an unforeseen data set. Okay. So now you can calculate errors for all the predictions, and our model did not use the test data during training. So the test set error represent the model error on a unseen data, and that is what we have to worry about. So, the drawback of this approach is that it will significant amount of time, usually around 30%, okay, to use for the testing purpose. So, I just now showed you 33%, so almost equal to 30. This means that less training data and lower model quality. This is also a caveat. If you use a test data too much, error matrix will start to lie. For example, suppose that you did the following: train the model, measure the error on the test data, change the model and improve the metric, and repeat it the same time, deploy the model. So, this is the process we go for. So, what we call, it is likely that the quality of our model will be much lower than expected one. So, why this is happening, let us look at more closely. Step number 3, you look at a score and changing your model on the data processing code several number of consecutive time. In fact, you did several learning iterations by hand. So, this is what we call as a iterative process. You have to train your model epoch number 1, epoch number 2, epoch number 3 and so on and so forth. So, by repeating improving the test accuracy or score, you indirectly disclose the information about the test data to your model, and this is the underlying problem of my model. Okay. So, when the metric values are being measured on a test data set deviate from the metric used by the real data set, we say that the test data has leaked into our model. So, this is the biggest problem of this thing. So, data leaks are notoriously hard to detect because they cause a lot of damage. To avoid that, you should use a more mindful and possibly a leak, think critically and follow the best practices. We can use a separate piece of data to fight test state leakage. Okay. So, what we say that data scientists use a validation state. So, what I am going to do is, I have the two data set, I have split the data into two parts, I split into three parts. The three parts are very simple. I split the data set into three: training, validation and test. So, you can see that the test training data, I train the model. Validate data is like a dry run for my model, and validation test data is also a validating. So, what I can do is, I go on churning. So, first time I give a portion of the training data and test on a validation. Second time the validation data which was there, I test it on another one and become more and more. So, this is how we do it, and I do what we call as a training, validation and test. Now, when I do a what we call a vertical division of my data set, you can see here the validation model. First time I take the validation from here to here, so training becomes here. Next time I take the validation from here to here, the training become here. That means every training data point have a equally well good chances for becoming on a training data set and then validate data set. So, this is how our validation work. So, I stop here, and next time I am going to talk more about the validation details and how the validation work, how the matrix is to be measured. Thank you so much.